Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to today's Friday reflections on this half past midnight, early on Saturday morning, the 26th of August 2023. I hope you are well, wherever you're tuning into this from. And congratulations to the Indian Space Agency on their successful landing of a spacecraft and a rover on the moon's surface. This is a tremendous achievement by a young spacefaring. Of course, the first moon landings happened back in 1969, although there are still some people within our communities that debate whether anybody has actually been to the moon. I mean, this is kind of tragic that we have such a low level of scientific literacy within our societies today. And this is amongst people of all faiths and none. I'm able to communicate with you at this moment through Instagram, through YouTube, through the internet, using technologies that were developed using science. Firstly, my phone and laptop would not be able to connect to any internet without Wi-Fi. Wi-Fi would not exist without radio. And then through the various protocols that are used over these mediums, we establish connection. But without optics, which was actually a science started by a Muslim, we wouldn't have an image. You would not be able to see me. Without recording technologies, you would not be able to hear me. In short, my brothers and sisters, everything which is happening right now is based upon scientific development and the technologies that are built upon that. So it is really vital that we have at least a general level of scientific literacy. It is something which I often mention in my sohbets. I have long had an interest in science, long before I had an interest in any particular religion. And this interest in science and my scientific approach to things, even to a degree, the way I approached my spiritual journey and my religious journey, was based upon my scientific approach and scientific understanding. So this is why I reiterate it. And today, instead of reading a religious book, I'm actually going to read from a scientific book. This is a classic scientific text of modern times, Cosmos by Carl Sagan. This has also been turned into two different TV series, one produced by Carl Sagan himself, where he was actually hosting it, and another one that was produced by Neil deGrasse Tyson, or hosted by him anyway. And I'm going to begin with chapter 1. I'll skip the introduction, but I'll begin with chapter 1. The shores of the cosmic ocean. Begins with a quote from the Popol Vuh of the Quiche Maya. This is a South American nation. The first men to be created and formed were called the sorcerer of fatal laughter, the sorcerer of night, unkept, and the black sorcerer. They were endowed with intelligence. They succeeded in knowing all that there is in the world. When they looked, instantly they saw all that is around them, and they contemplated in turn the arc of heaven and the round face of the earth. Then the Creator said, "They know all. What shall we do with them now? Let their sight reach out only to that which is near. Let them see only a little of the face of the earth. Are they not by nature simple creatures of our making? Must they also be gods?" And another quote from the book of Job in the Bible: "Have you comprehended the expanse of the earth? There is the way to the dwelling of light, and where is the place of darkness?" A quote from Blaise Pascal, Pensies: "It is not from space that I must seek my dignity, but from the government of my thought. I shall have no more if I possess worlds. By space, the universe encompasses and swallows me up like an atom. By thought, I comprehend this world." And another by T.H. Huxley, 1887: "The known is finite, the unknown infinite. Intellectually, we stand on an islet in the midst of an unlimitable ocean of inexplicability. Our business in every generation is to reclaim a little bit more land," which means that this last quote is quite sort of beautiful language and stuff, but it's not so clear what he's getting at. It's what is known is limited, and what is known is unlimited. And there is a vast ocean that we just still do not know anything about. I mean, this was in the late 19th century. A lot's been discovered since, but it's still true. And he said, our business in every generation is to reclaim a little bit more land. In other words, to try to learn and to gain some of that which is unknown or unknown to those previously. The cosmos is all that is, or ever was, or ever will be. Our feeblest contemplations of the cosmos stir us. There is a tingling in the spine, a catch in the voice, a faint sensation as if a distant memory of falling from a height. We know we are approaching the greatest of mysteries. The size and age of the cosmos are beyond ordinary human understanding. Lost somewhere between immensity and eternity is our tiny planetary home. In a cosmic perspective, in the last few, the cosmos and our place within it. Explorations that are exhilarating to consider. They remind us that humans have evolved to wonder, that understanding is a joy, that knowledge is a prerequisite to. I believe our future depends on how well we know this cosmos, in which we float like a mote of dust. This is science, but you think of the reflection there, just in these first couple of paragraphs, about the cosmos is all that there is. The universe is another word for cosmos. It's all that there is in this physical existence that we can directly relate to. Now, there may be other universes. The string theory postulates that. This was not something which I think Carl Sagan goes into here, because I think this has been developed much more since he wrote the book, which was going back a bit now. It's 1981. So obviously string theory has developed a lot within the past 4 decades. So he's talking about the universe as was understood then. And even that physical universe is vast. We don't really know the limits of it. There are estimations, and then they grow. As you know, it's like recently the new telescope, the James Webb telescope, has seen galaxies and stars which are further away than what Hubble saw, which is making scientists to reassess the size of our universe. It's vast. The distance between stars is measured in light years. Now I'm sitting in a room and there's a light there and there's a light here. That light seems instantaneous to us. It doesn't seem like it's even traveling. It's just there. Turn the light on, it's there. But actually, light travels, light moves. The light from the sun, I think it takes about 8 minutes to get to the earth. So the distance between stars is measured in light years. Those little tiny stars that you see in the sky are actually huge. Some of them are bigger than our sun. And that light may have taken centuries to reach the earth. So that's how the distance is measured. It's actually not measured in meters or kilometers or miles. It's measured in the amount of time it gets to and from these places. It gives you some idea of the vastness of this cosmos. And from a religious perspective, you can say the vastness of Allah's creation. I mean, when I read about these things, for me, it never diminishes my faith, it expands it. And this is what Carl Sagan says here. The size and age of the cosmos are beyond ordinary human understanding. It's really mind-boggling, even for those people who study this all of the time. But there's still a benefit in understanding that. And it makes us realize how small this earth is. And the things that as humans often put value on, how small are those things in comparison to this universe? It's not even, our earth is like a speck of dust. Carl Sagan continued, those explorations required skepticism and imagination both. Imagination will often carry us to worlds that never were, but without it, we go nowhere. Skepticism enables us to distinguish fancy from fact, to test our speculations. The cosmos is rich beyond measure in elegant facts, in exquisite interrelationships, in the subtle machinery of awe. He highlights an important point here. To understand science, to sort of increase our understanding, we need imagination. This is not something that's immediately obvious, because people don't often think of imagination with science, because science is concerned with facts. But in order to get to those facts, you need imagination. Einstein himself, he used to do thought experiments where he would imagine riding on a light beam from the sun. Think about that. These are things that went through Einstein's mind, and compare that to what goes through the average person's mind. And this helped him to work out his theories, which were then tested to see whether they worked or not. Actually, there were hypotheses that were tested and then they became theories. In science, a theory is as good as a fact. It's not mean the same as theory in normal English. The surface of the earth is the shore of the cosmic ocean. From it, we have learned much of what we know. Recently, we have waded a little out to sea, enough to dampen our toes, or at most, wet our ankles. The water seems inviting. The ocean. Some part of our being knows this is from where we came. We long to return. These aspirations are not, I think, irrelevant, although they may trouble whatever gods may be. The dimensions of the cosmos are so large that using familiar units of distance, such as meters or miles, chosen for their utility on Earth, would make little sense. Instead, we measure distance with the speed of light. In 1 second, a beam of light travels 186,000 miles, nearly 300,000 kilometers, or 7 times around the Earth. In 8 minutes, it will travel from the sun to the Earth. We can say the sun is 8 light minutes away. In a year, it crosses nearly 10 trillion kilometers, about 6 trillion miles of intervening space. That unit of length, the distance light goes in a year, is called a light year. It measures not time, but distances, enormous distances. The Earth is a place. It is by no means the only place. It is not even a typical place. No planet or star or galaxy can be typical because the cosmos is mostly empty. The only typical place is within the vast, cold, universal vacuum, the everlasting night of intergalactic space, a place so strange and desolate that by comparison, planets and stars and galaxies seem achingly rare and lovely. If we were not randomly inserted into the cosmos, the chance that we would find ourselves on or near a planet would be less than 1 in a billion trillion trillion. 10 to the power of 33. That's a 1 followed by 33 zeros. In everyday life, such odds are called compelling. Worlds are precious. See, do you understand what Carl Sagan is saying here? If we roll the dice and we randomly appeared anywhere in the universe, the chances that we would appear on or even near a planet would be less than 1 in a billion trillion trillion. Even though there's so many stars in this universe and so many planets around those stars, but because of the vastness of space, most of space is literally, it's space. That's why it's called space. It's a vacuum. There's nothing there. Maybe today they're postulating there might be some kind of dark matter or something, and scientists are trying to discover this. But other than that, there's nothing else there. There's certainly no planets or no worlds. So we're quite in an incredibly rare situation. And again, that doesn't give you faith. I don't know what would. I mean, for me, it's just remarkable. Even scientists admit that. In everyday life, such odds are called compelling. Worlds are precious. From an intergalactic vantage point, we could see, strewn like sea froth on the waves of space, innumerable, faint, wispy tendrils of light. These are the galaxies. Some are solitary wanderers. Most inhabit communal clusters, huddling together, drifting endlessly in the great cosmic dark. Before us is the cosmos on the grandest scale we know. We are in the realm of the nebulae, 8 billion light years from Earth, halfway to the edge of the known universe. A galaxy is composed of gas and dust and stars, billions upon billions of stars. Every star may be a sun to someone. Within a galaxy are stars and worlds, and it may be a proliferation of living things and intelligent beings and spacefaring civilizations. But from afar, a galaxy reminds me more of a collection of lovely found objects, seashells, perhaps, or corals, the productions of nature laboring for aeons in the cosmic ocean. There are some 100 billion, that's 10 to the power of 11, galaxies, each with, on average, 100 billion stars. In all the galaxies, there are perhaps as many planets as stars. 10 to the power of 11 times 10 to the power of 11 equals 10 to the power of 22. 10 billion trillion. In the face of such overpowering numbers, what is the likelihood that only one ordinary star, the Sun, is accompanied by an inhabited planet? Why should we, tucked away in some forgotten corner of the cosmos, be so fortunate? To me, it seems far more likely that the universe is brimming over with life, but we humans do not yet know. We are just beginning our explorations. From 8 billion light years away, we are hard pressed to find even the cluster in which our Milky Way galaxy is embedded, much less the Sun or the Earth. The only planet we are sure is inhabited is a tiny speck of rock and metal shining feebly by reflected sunlight, and at this distance, utterly lost. You understand what Carl Sagan here is saying is the universe, he believes, is likely to be full of life, because what are the chances when there are 10 billion, was it some 100 billion galaxies, each with 100 billion stars and around 10 billion trillion planets? What are the chances that our Earth is the only one that's got life on it? There must be billions or trillions of habitable planets. On some, life would have evolved. On some of those, intelligent life would have evolved. Some of those may have made it into space and become advanced civilizations. As yet, we don't know how many there are. But if you contemplate, each one of those stars is a sun. Around each of those suns, there would be planets. At least some of those planets are going to have intelligent life on them. But the distances are vast. I mean, if you were, Carl Sagan says 8 billion light years away. So if you were on the other side of the universe, you wouldn't even be able to see our sun, let alone the Earth. He continues that presently our journey takes us to what astronomers on Earth like to call the local group of galaxies, several light years across. It is composed of some 20 constituent galaxies. It is a sparse and obscure and unpretentious cluster. One of these galaxies is M31, seen from the Earth in the constellation Andromeda. Like other spiral galaxies, it is a large pinwheel of stars, gas, and dust. M31 has two small satellites, dwarf elliptical galaxies bound to it by gravity, by the identical law of physics that tends to keep me in my chair. The laws of nature are the same throughout the cosmos. We are now 2 million light years from home. Beyond M31 is another very similar galaxy, our own. Its spiral arms turning slowly, once every quarter of a billion years. Now, 40,000 light years from home, we find ourselves falling towards the massive center of the Milky Way. But if we wish to find the Earth, we must redirect our course to the remote outskirts of the galaxy, to an obscure locale near the edge of a distant spiral arm. Our overwhelming impression, even before the spiral arms, is of stars streaming by us, a vast array of exquisitely self-luminous stars, some as flimsy as a soap bubble, and some as large that they could contain 10,000 suns or a trillion Earths. Others the size of a small town, and 100 trillion times denser than lead. Some stars are solitary, like the sun. Most have companions. Systems are commonly double, two stars orbiting one another. But there is a continuous gradation from triple systems through loose clusters of a few dozen stars to the great globular systems, resplendent with a million stars. Some double stars are so close that they touch, and star stuff flows between them. Most are as separated as Jupiter is from the sun. Some stars, the supernovae, are as bright as the entire galaxy that contains them. Others, the black holes, are invisible from a few kilometers away. Some shine with a constant brightness, others flicker uncertainly or blink with an unfaltering rhythm. Some rotate in stately elegance, others spin so feverishly that they distort themselves to oblateness. Most shine in visible and infrared light, others are also brilliant sources of X-rays or radio waves. Blue stars are hot and young, yellow stars conventional and middle-aged, red stars often elderly and dying. White or black stars are in the final throes of death. The Milky Way contains some 400 billion stars of all sorts, moving with a complex and orderly grace. Of all the stars, the inhabitants know close up so far but one. So there's about 400 billion stars in our Milky Way galaxy alone. So, it's amazing when you think about that. How many planets in our Milky Way galaxy if there are 400 billion stars? Each star system is an island in space, quarantined from its neighbors by the light years. I can imagine creatures evolving into glimmerings of knowledge on innumerable worlds, every one of them assuming at first their puny planet and paltry few suns to be all that there is. We grow up in isolation. Only slowly do we teach ourselves the cosmos. Some stars may be surrounded by millions of lifeless and rocky worldlets, planetary systems frozen at some early stage in their evolution. Perhaps many stars have planetary systems rather like our own. At periphery, great gaseous ringed planets and icy moons, and nearer to the center, small, warm, blue-white, cloud-covered worlds. On some, intelligent life may have evolved, reworking the planetary surface in some massive engineering enterprise. These are our brothers and sisters in the cosmos. Are they very different from us? What is their form? Biochemistry, neurobiology, history, politics, science, technology, art, music, religion, philosophy? Perhaps someday we will know them. We have now reached our own backyard, a light year from Earth. Surrounding our sun is a spherical swarm of giant snowballs composed of ice and rock and organic molecules, the cometary nuclei. Every now and then, a passing star gives a tiny gravitational tug, and one of them obligingly careens into the inner solar system. There the sun heats it, the ice is vaporized, and a lovely cometary tail develops. This is where comets come from. We approach the planets of our system, largest worlds, captives of the sun, gravitationally constrained to follow nearly circular orbits, heated mainly by sunlight. Pluto, covered with methane ice and accompanied by its solitary giant moon Charon, is illuminated by a distant sun, which appears no more than a bright point of light in a pitch black sky. The giant worlds, Neptune, Uranus, Saturn, the jewel of the solar system, and Jupiter, all have an entourage of icy moons. Interior to the region of gassy planets and orbiting icebergs are warm, rocky provinces of the inner solar system. There is, for example, the red planet Mars, with soaring volcanoes, great rift valleys, enormous planet-wide sandstorms, and just possibly some simple form of life. The planets orbit, also all the planets orbit the sun, the nearest star, an inferno of hydrogen and helium gas engaged in thermonuclear reactions, flooding our solar system with light. Finally, at the end of all our wanderings, we return to our tiny, fragile, blue-white world, lost in a cosmic ocean vast beyond our most courageous imaginings. It is a world among an immensity of others. It may be significant only for us. The Earth is our home, our planet. Our kind of life arose and evolved here. The human species is coming of age here. It is on this world that we are developing our passion for exploring the cosmos, and it is here that we are, in some pain and with no guarantees, working out our destiny. Welcome to the planet Earth, a place of blue nitrogen skies, oceans of liquid water, cool forests, and soft meadows, a world positively rippling with life. In the cosmic perspective, it is, as I have said, poignantly beautiful and rare. But it is also, for the moment, unique. In all our journeying through space and time, it is, so far, the only world on which we know with certainty that the matter of the cosmos has become alive and aware. There must be many such worlds scattered through space, but our search for them begins here with the accumulated wisdom of the men of our species, garnered at great cost over 1,000,000 years. We are privileged to live among brilliant and passionately inquisitive people, and in a time when the search for knowledge is generally prized. And even there's been a decline, I think, in some ways, in the general populace since Carl Sagan wrote those words. Nonetheless, there's still a lot of people on this earth who do value science and study the sciences. Human beings, born ultimately of the stars and now for a while inhabiting a world called Earth, have begun their long voyage home. The discovery that the Earth is a little world was made, as so many important human discoveries were, in the ancient Near East. In a time some humans call the 3rd century BC, in the greatest metropolis of the age, the Egyptian city of Alexandria. Here there lived a man named Eratosthenes. One of his envious contemporaries called him Beta, the second letter of the Greek alphabet. because Eratosthenes was second best in the world in everything. But it seems clear that in most everything, Eratosthenes was alpha. He was an astronomer, historian, geographer, philosopher, poet, theatre critic, and mathematician. The titles of the books he wrote range from astronomy to On Freedom from Pain. He was also the director of the Great Library of Alexandria, where one day he read in a papyrus book that in the southern frontier outpost of Syene, near the first cataract of the Nile, at noon on June 21st, vertical sticks cast no shadows. On the summer solstice, the longest day of the year, as the hours crept towards midday, the shadows of temple columns grew shorter. At noon, they were gone. A reflection of the sun could then be seen in the water at the bottom of a deep well. The sun was directly overhead. It was an observation that someone else might easily have ignored. Sticks, shadows, reflections in wells. The position of the sun. Of what possible importance could such simple, everyday matters be? But Eratosthenes was a scientist, and his musings on these commonplaces changed the world. In a way, they made the world. Eratosthenes had the presence of mind to do an experiment, actually to observe whether in Alexandria vertical sticks cast shadows near noon on June 21st. And he discovered sticks do. Eratosthenes asked himself how, at the same moment, a stick in Syene could cast no shadow, and a stick in Alexandria, far to the north, could cast a pronounced shadow. Consider a map of ancient Egypt with two vertical sticks of equal lengths, one stuck in Alexandria, the other in Syene. Suppose that, at a certain moment, each stick casts no shadow at all. This is perfectly easy to understand, provided the earth is flat. The sun would then be directly overhead. If the two sticks cast shadows of equal length, that also would make sense on a flat earth. The sun's rays would then be inclined at the same angle to the two sticks. But how could it be that at the same instant there was no shadow at Syene and a substantial shadow at Alexandria? The only possible answer he saw was that the surface of the earth is curved. Not only that, the greater the curvature, the greater the difference in the shadow lengths. The earth is so far away that its rays are parallel when they reach, the sun is so far away that its rays are parallel when they reach the earth. Sticks placed at different angles to the sun's rays cast shadows of different lengths. For the observed difference in the shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the earth. That is, if you imagine the sticks extending down to the center of the earth, they would there intersect at an angle of 7 degrees. 7 degrees is something like 1/50th of 360 degrees, the full circumference of the earth. Eratosthenes knew that the distance between Alexandria and Syene was approximately 800 kilometers because he hired a man to pace it out. 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the earth. This is the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains. plus a taste or experiment. With them, he deduced the circumference of the Earth with an error of only a few percent, a remarkable achievement for 2,200 years ago. He was the first person to accurately measure the size of a planet. So 2,200 years ago, this Greek guy in Egypt, Eratosthenes, managed to calculate the size of the Earth. You might think you would need to measure all of the Earth in order to do that, or to have a satellite in space. But they do use these technologies now to refine his calculation. But he measured it using a stick in the ground at Alexandria and a stick in the ground at Syene. I'm sorry, I don't know if I'm pronouncing this right, Syene. And based upon the fact that working out from the shadow, the fact that this one had no shadow and this one had a shadow, even though they're the same length. So there must be an angle there. He worked out, firstly, that the Earth must be round. It can't be flat. And secondly, from the angle, he deduced he calculated the circumference of the Earth using that, just the angle and the height of the sticks. I mean, and the distance between the sticks, which was 800 kilometers. And using this 2,200 years ago, he calculated the circumference of the Earth. I mean, how remarkable is that? And yet today, we've still got some people who think the Earth is flat. 2,200 years ago, this Greek scientist, Eratosthenes, already calculated the circumference of the Earth, and you can't blame that on, some modern conspiracy. I mean, what an achievement. The Mediterranean world at that time was famous for seafaring. Alexandria was the greatest seaport on the planet. Once you know the Earth to be a sphere of modest diameter, would you not be tempted to take voyages of exploration, to seek out undiscovered lands, perhaps even to attempt to sail around the planet? 400 years before Eratosthenes, Africa had been circumnavigated by a Phoenician fleet in the employ of the Egyptian pharaoh Necho. They set sail, possibly in frail, open boats from the Red Sea, turned down the east coast of Africa, up into the Atlantic, returning through the Mediterranean. This epic journey took 3 years, about as long as the modern Voyager spacecraft takes to fly from Earth to Saturn. After Eratosthenes' discovery, many great voyages were attempted by brave and venturesome sailors. Their ships were tiny. They had only rudimentary navigational instruments. They used dead reckoning and followed coastlines as far as they could. In an unknown ocean, they could determine their latitude, but not their longitude. By observing night after night the position of the constellations with respect to the horizon, the familiar constellations must have been reassuring in the midst of an unexplored ocean. The stars are friends of explorers. Then with seagoing ships on Earth and now with spacefaring ships in the sky. After Eratosthenes, some may have tried, but not until the time of Magellan did anyone succeed in circumnavigating the Earth. What tales of daring and adventure must earlier have been recounted as sailors and navigators, practical men of the world, gambled their lives on the mathematics of a scientist from Alexandria. In Eratosthenes' time, globes were constructed, portraying the Earth as viewed from space. They were essentially correct in the well-explored Mediterranean, but became more and more inaccurate the further they strayed from home. At present, knowledge of the cosmos shares this disagreeable but inevitable feature. In the first century, the Alexandrian geographer Strabo wrote, "Those who have returned from an attempt to circumnavigate the earth do not say they have been prevented by an opposing continent, for the sea remained perfectly open, but rather through want of resolution and scarcity of provision. Eratosthenes says that if the extent of the Atlantic Ocean were not an obstacle, we might easily pass from Iberia to India. It is quite possible that in the temperate zone there may be one or two habitable earths. Indeed, if this other part of the world is inhabited, it is not inhabited by men such as exist in our parts, and we should have to regard it as an other inhabited world." This is where the concept of the new world comes from. Humans were beginning to venture in almost every sense that matters to other worlds. The subsequent exploration of the Earth was a worldwide endeavor, including voyages from as well as to China and Polynesia. The culmination was, of course, the discovery of America by Christopher Columbus and the journeys of the following few centuries. Although, of course, we know Christopher Columbus was not the first from Europe anyway, to discover the Americas. We now know that Viking explorers went there before Christopher Columbus, and also African explorers from West Africa. But when the book was written, Sagan quotes Christopher Columbus. Connected in the most straightforward way with the of Eratosthenes. Columbus was fascinated by what he called the enterprise of the Indies, a project to reach Japan, China, and India, not by following the coastline of Africa and sailing east, but rather by plunging boldly into an unknown Western Ocean, or as Eratosthenes had said with startling prescience, to pass by sea from Iberia to India. Columbus had been an itinerant peddler of old maps and an assiduous reader of the books by and about the ancient geographers, including Eratosthenes, Strabo, and Ptolemy. But for the enterprise of the Indies to work, for ships and crews to survive the long voyage, the earth had to be smaller than Eratosthenes had said. Columbus therefore cheated on his calculations, as the examining faculty of the University of Salamanca quite correctly pointed out. He used the smallest possible circumference of the earth and the greatest eastward he could find in all the books available to him, and then even those. Had the Americas not been in the way, Columbus's expeditions would have failed utterly. You see, Columbus didn't know America was there. Even the first time Columbus went to America, he thought he'd arrived in the East Indies. So he thought he had arrived somewhere by Indonesia or India or something. He didn't realize that he'd actually landed in a new continent, or a new continent to Europeans, which is interesting because the Vikings had already discovered North America. Although, of course, Columbus discovered the Caribbean, so it's a bit further south. But apparently, according to Carl Sagan here, and the University of Salamanca, he cheated on his calculations of provisions. So if America had not been there, then either his expeditions would have failed or he'd have died at sea or something. The Earth is now thoroughly explored. Now, Carl Sagan says that, but I would say that's not strictly true. The surface of the Earth might be to a large extent explored, but the depths of the ocean are still being discovered, new things that we didn't know before. There's also, what's beneath our feet in the ground. They're finding things all the time. So it's not strictly true to say it's thoroughly explored, but I think he just means generally. It no longer promises new continents or lost lands, but the technology that allowed us to explore and inhabit the most remote regions of the Earth now permits us to leave the planet, to venture into space, to explore other worlds. Leaving the Earth, we are now able to view it from above, to see its solid spherical shape of Eratosthenean dimensions and the outlines of its continents, confirming that many of the ancient map makers were remarkably competent. What a pleasure to see a view others. Sorry, what a pleasure such a view would have given to Eratosthenes and other Alexandrian geographers. It's a shame they couldn't see it, in other words. And if they could, how happy they would have been. It was in Alexandria during the 600 years beginning around 300 BC that human beings, in an important sense, began the intellectual adventure that has led us to the shores of space. But of the look and feel of that glorious marble city, nothing remains. Opposition and the fear of learning have obliterated all memory of ancient Alexandria. Its population was marvelously diverse. Macedonian and later Roman soldiers, Egyptian priests, Greek aristocrats, Phoenician sailors, Jewish merchants, visitors from India and sub-Saharan Africa. Everyone, except the vast slave population, lived together in harmony and mutual respect for most of the period of Alexandria's greatness. The city was founded by Alexander the Great and constructed by his former bodyguard. Alexander encouraged respect for alien cultures, i.e. foreign cultures, and the open-minded pursuit of knowledge. According to tradition, and it does not matter whether it really happened, he descended beneath the Red Sea in the world's first diving bell. He encouraged his generals and soldiers to marry Persian and Indian women. He respected the gods of other nations. He collected exotic life forms, including an elephant for Aristotle, his teacher. His city was constructed on a lavish scale to be the world center of commerce, culture, and learning. It was graced with broad avenues, 30 meters wide, architecture, and a statuary. Alexander's monumental tomb and an enormous lighthouse, the Pharos, one of the seven wonders of the ancient world. But the greatest marvel of Alexandria was the library and its associated museum, literally an institution devoted to the specialities of the nine muses. Of that legendary library, the most that survives today is a dank and forgotten sala of the Serapeum, the library annex, once a temple and later reconsecrated to knowledge. A few mouldering shelves may be its only physical remains. Yet this place was once the brain and glory of the greatest city on the planet, the first true research institute in the history of the world. The scholars of the library studied the entire cosmos. The cosmos is a Greek word for the order of the universe. It is, in a way, the opposite of chaos. It implies the deep interconnectedness of all things, It conveys awe for the intricate and subtle way in which the universe is put together. Here was a community of scholars exploring physics, literature, medicine, astronomy, geography, philosophy, mathematics, biology, and engineering. Science and scholarship had come of age. Genius flourished here. The Alexandrian Library is where humans first collected seriously and systematically the knowledge of the world. In addition to Eratosthenes, there was the astronomer Hipparchus, who mapped the constellations and estimated the brightness of the stars. Euclid, who brilliantly systemized geometry and told his king, struggling over a different mathematical problem, there is no royal road to geometry. Dionysius of Thrace, the man who defined the parts of speech and did a study of language for what Euclid did for geometry. Herophilus, the physiologist who firmly established that brain rather than heart is the center of intelligence. Heron of Alexandria, inventor of the gear trains and steam engines, and the author of Automata, the first book on robots. Apollonius of Perga, the mathematician who demonstrated the forms of conic sections, ellipse, parabola, and hyperbola, the curves as we now know followed in their orbits by the planets, the comets, and the stars. Archimedes, the greatest mechanical genius until Leonardo da Vinci, and the astronomer and geographer Ptolemy, who compiled much of what is today the pseudoscience of astrology. His Earth-centered universe held sway for 1,500 years. A reminder that intellectual capacity is no guarantee against being dead wrong. And among those great men was a great woman, Hypatia, a mathematician and astronomer, the last light of the library whose martyrdom was bound up with the destruction of the library 7 centuries after its founding, a story to which we will return. The Greek kings of Egypt who succeeded Alexander were serious about learning. For centuries, they supported research and maintained in the library a working environment for the best minds of the age. It contained 10 large research halls, each devoted to a separate subject, fountains and colonnades, botanical gardens, a zoo, dissecting rooms, an observatory, and a great dining hall where at leisure was conducted the critical discussion of ideas. The heart of the library was its collection of books. I mean, think about this. This is going back to the time of Alexander the Great. And then it was developed for 7 centuries until its destruction. We have not got the first scientific revolution in modern times. There have been many scientific revolutions in human history. And the warning here is how people can be so enlightened and so educated and then fall into the darkness of ignorance, the jahiliyyah that the Prophet Muhammad fought and struggled so much against. The organizers combed all cultures and languages of the world. They sent agents abroad to buy up libraries. Commercial ships docking in Alexandria were searched by the police, not for contraband, but for books. The scrolls were borrowed, copied, and then returned to their owners. Accurate numbers are difficult to estimate, but it seems probable that the library contained 500,000 volumes, with each a handwritten papyrus scroll. What happened to all those books? The classical civilization that created them disintegrated, and the library itself was deliberately destroyed, not accidentally, deliberately destroyed. What a crime against humanity. 500,000 books, at least, destroyed. Only a small fraction of its work survived, along with a few pathetic scattered fragments, and how tantalizing those bits and pieces are. We know, for example, that there was on the library shelves a book by the astronomer Aristarchus of Samos, who argued that the Earth is one of the planets, which, like them, orbits the Sun, and that the stars are enormously far away. Each of these conclusions is entirely correct, but we had to wait nearly 2,000 years for their rediscovery. If we multiply by 100,000 our sense of loss for this work of Aristarchus, we begin to appreciate the grandeur of the achievement of classical civilization and the tragedy of its destruction. We have far surpassed the science known to the ancient world, but there are irreparable gaps in our historical knowledge. Imagine what mysteries about our past could be solved with a borrower's card to the Alexandrian library. We know of a 3-volume history of the world, now lost, by a Babylonian priest named Berosus. The first volume dealt with the interval from the creation to the flood, a period he took to be 432,000 years, or about 100 times longer than the Old Testament chronology. I wonder what was in it. The ancients knew that the world is very old. They sought to look into the distant past. We now know that the cosmos is far older than they ever imagined. We have examined the universe in space and seen that we live on a mote of dust circling a humdrum star in the remotest corner of an obscure galaxy. And if we are a speck in the immensity of space, we also occupy an instant in the expanse of ages. We now know that our universe, or at least its most recent incarnation, is some 15 or 20 billion years old. This is the time since a remarkable explosive event called the Big Bang. At the beginning of this universe, there were no galaxies, stars, or planets, no life or civilizations, merely a uniform, radiant fireball filling all of space. The passage from the chaos of the Big Bang to the cosmos that we are beginning to know is the most awesome transformation of matter and energy that we have been privileged to glimpse. And until we find more intelligent beings elsewhere, we are ourselves the most spectacular of all the transformations, the remote descendants of the Big Bang, dedicated to understanding and further transforming the cosmos from which we sprang. From which we spring. Yeah. So that is the first chapter of Cosmos, a book by Carl Sagan, which there is also an accompanying series that was made in his lifetime, which is one of my favorite TV shows. It's beautiful. And also a few years ago, there was another series hosted by Neil deGrasse Tyson that kind of built upon that and updated it. I hope you enjoyed that. It's a bit different from my usual Friday reflections. But reflections are reflections. They are for us to think and to understand. The Prophet Muhammad struggled against Jahiliyyah and encouraged us to gain knowledge, ilm, to learn. We should learn. It's a duty on us as Muslims to learn. And learning knowledge doesn't just mean learning religious knowledge, but learning all kinds of knowledge. And scientific knowledge is a really vital aspect of knowledge that we should at least, even if it is not our field, we should at least have some general knowledge about, a reasonably good understanding of, not necessarily in depth, but at least a general understanding of it, and an understanding of how science itself works, the mechanism of science. because so much of today's world is built on science. You can't really understand anything if you don't have a scientific understanding. And this is also fulfilling a religious duty that we have as Muslims. And yet, time after time, even probably not a day or a week goes by where I hear or read some post that is totally unscientific, totally inaccurate, and yet the person is stating it as if it is absolute fact, when it is provably not. Now, if this is just a matter of an individual opinion here or there, it doesn't really matter too much. But if that person has influence and influences 100 people or 200 people or 1,000 or 10,000 people to think like they do, how are those people going to make headway in the modern world? How are those people going to become enlightened human beings? You see what I'm saying? It becomes a really dangerous problem when influential people are promoting jahiliyyah. This is literally the meaning of jahiliyyah. Jahiliyyah was the time of ignorance. When our scientific understanding has reached new heights that far surpassed what the understanding was in medieval times, let alone in the 7th century. How can we properly come to a good understanding of our religion and a good paradigm within our religion, but also within our world, that we can use to govern our lives if we do not have a good understanding of science? It's truly vital. And that's why today I have read a scientific book, and this is why I have previously highlighted the importance of improving our scientific literacy. We indeed have a problem. And yet, if you trace the modern scientific revolution, you could say, that began in Europe, it actually didn't begin in Europe. It began in the Muslim world, where they learned from some of the books that copies were elsewhere of the books that were in the Library of Alexandria, for instance, and translated them into Arabic and studied them. And you had Muslim scientists who wrote their own books. They wrote their own commentaries on Aristotle, for instance, who was mentioned here. And then these books were then later translated into Latin and other European languages and inspired the Europeans out of their own dark ages, out of their own Jahiliyyah. Europe was in Jahiliyyah during what we call dark ages. Dark ages, what does it mean? It means Jahiliyyah. And it took Europeans from dark ages into the Renaissance. Instead of burning witches, they started learning the sciences. They started learning technologies. They started, building the modern technologies that we see all around us today, improving their hygiene, being able to prescribe medicines that actually worked, and disease started to diminish. General health started to improve. So many benefits have come from that. And yet I see in some other countries, people to this day take things as medicines which are probably ineffective, or scratch coins on their back when they have a cold or flu. How's that going to improve a person's health? We need to understand things in a better way, and it's not as if we aren't living in a time where that knowledge isn't available to us. And fuse that knowledge with the best understanding of our religion as Muslims? What a great combination that would be, that we could inform our lives and become much better human beings. This is what inspires me. I wish you all have a wonderful day wherever you are. I'm going to sign off now. I hope you enjoyed that. I hope you benefit from that. And I hope to see you all again on Monday. Actually, Monday, I'm just thinking. I might not be able to do the Monday because I have something on. If not, I might do it the day before, after, we'll see. Anyway, you take care. I wish you all the very best. Have a wonderful weekend. Assalamu alaikum wa rahmatullahi wa barakatuh. May the peace and blessings of God be with you all.